Hello everybody and welcome back to the 2000 Pascal paper. We're up to question number 17. Question number 17, short and sweet. In the diagram, the value of height h is... Alright, and that's what we're left to figure out. We've got a right angle here, a right angle there, although they haven't included it, and a right angle up here. So let's see what we can do. Okay. So... first thing I'm noticing is, hey, this one up here is a right angle, so I should be able to use the Pythagorean theorem to get this missing side length for the big triangle. Okay. So we have 20 over here, we have 25 over here. We have h in here. And let's give this guy a name x. So since this is a right angle triangle, I know that 25 squared is going to be 20 squared plus x squared. And that means that x is going to be the square root of 25 squared minus 20 squared. And that should be 625 minus 400, 225, so square root of 225. 15. Okay. So now my triangle looks like this. 15, 20, and 25. You'll notice that this is really just a 3, 4, 5 triangle in disguise. But how do we get this pesky h? Well, we know, for example, that it's a height. Okay. I can see two ways to do this. One, the way I'm going to do it by noticing that it's a height. The other way by using these other right angle triangles and maybe saying, okay, well this is going to be y in here, this will be 25 minus y. And then we can work out the common value of y, and then from there we can get h. That's certainly something that we can do, I think. Yeah, will that work? Yeah, we'll be able to substitute in for h in terms of y, and then figure out what y is because we know what 20. We know we're going to get 20 over there. Yeah, so that would definitely work. But I think the easier way to realize it is h is a height. So the area is 1/2 base, which is 25, times height. Now, in and of itself, that's irrelevant. I mean, well, not irrelevant, but it can't be used in any meaningful way. If we had another way to compute the height in terms of h or in terms of an actual value, we'd be all set. So let's just rotate our triangle a little bit. And we see that, oh my, we do have another way to compute the height. We have a base times height of the triangle. We just, it's not easily apparent. We have to sort of rotate the triangle. So the area is also equal to 1/2 base, 15, times height, which in this case is 20. So it's a good thing we figured out that other side. Okay? It wasn't immediately obvious that we needed to figure out the other side, but we had the capability by using Pythagoras' theorem, and it's never bad to get a little extra information. So now we know that 1/2 of 25h is the same as 1/2 of 15 times 20. Well, this side becomes the 2 and the 20 cancel each other out to leave 10. So 15 times 10, that's 150. And 25 over 2h. So if we want h by itself, we need to get rid of this 25 over 2, so we flip it and multiply it on the other side. 25 goes in 156 times, so we should get 2 times 6. So we should get a final answer of 12, but let me just check that out. 150 divided by 25, yep, that was 6. Multiplied by 2, we get 12. So let's see, is 12 one of our potential answers? Yes, it is. It's D. But as I say, there's no shame in saying, in trying to use Pythagoras' theorem a little more and having a y down here and a 25 minus y down here. What you'll get is 15, 12, and 9. So it's another 3, 4, 5 triangle. And down here you'll have 20, 16, and 12 as well. So that's what you'll get. You'll get y is 9 if you do it that way, and that's a perfectly reasonable way to do it. But I like my comparing areas method. I think it's a little slicker. Anyway, no matter how you did it, hopefully you got the right answer. And in the next question, we'll take a look at number 18. So I'll see you guys then.